This is Chapter 7, the theory of costs. So this is going to use the material in Chapter 6 on production functions to actually develop cost curves, which we're going to use to derive supply curves. The key to cost is opportunity costs. Opportunity costs are the benefit from the next best choice. This means that if you could make $1 million in this industry, $800,000 in another industry, what industry would you pick? Well, you'd rather pick the million than the 800,000. $800,000 then represents an opportunity cost. We're going to add those opportunity costs into our costs. The reason I'm talking about that is because that's crucially important for defining profit. Because as an economist, we want to talk about economic profit, which is the profit you make over and above your opportunity cost. That means that a firm that makes profit of zero is actually doing fine because it's doing as well as it could on its next best opportunity. So have opportunity costs in mind. We use it all the time in every economic decision making. The book, after talking about the definition of profit, talks about sunk costs. They're interesting because they're costs that don't affect what you do. Why don't they affect what you do? Well, because it already happened and you can't do anything about it. So, for example, would you run your business differently this year if you lost money last year or if you made money last year? And the answer is, well, if you're making as much money as possible, we're assuming these firms maximize profit, then whether you made money or lost money last year shouldn't affect your decisions this year. The book tells a funny story, although it would be sad if it was your money, about a movie company that kept getting enticed to put a little bit more money into a project, and the project continued to be a disaster, and they lost boatloads of money. But they kept making their decision based on the margin. This last little bit of money is going to get more than they're going to put in, even though it's not going to make up for all the disasters that previously occurred. It's an example of how sunk costs should not affect your decision making, although you'd be glad not to be that movie company. So the costs are going to turn out to be parallel to inputs. Fixed inputs means fixed costs, and variable inputs means variable costs. So fixed inputs are those that don't change as output changes. Variable inputs are those that do change as output changes. Whether fixed costs are sunk costs or not is actually sort of immaterial to the way we're going to think about our problem. But they're really important because when you make your decision at the end about how much to produce, you're going to care about how much costs change when you produce one more output. Those costs are all variable costs. And we're going to call that a special name, marginal cost. You've heard of that before. Marginal costs are the cost of the last unit of output. That's the crucial thing that we need. In the book, table 7.1 presents the cost, a cost table for a firm just in terms of the totals. In table 7.2, it puts those into average and marginal costs. So that's dollars per unit of output. Why do they do that? It's because we're trying to get to a supply curve. If you remember, a supply curve has on the vertical axis price and then quantity on the horizontal axis. Price is dollars per unit, per each. So we convert our dollars per each so that we can talk about that. The book starts to do some graphs, talks much more carefully about marginal costs, which you need to be an expert of, since that's going to determine all the behaviors that we're going to talk about. And finally, on figure 7.4 is the crucial graph that shows average total cost, average variable costs, and marginal costs. One thing you should note is that the marginal costs are at the minimum of the average variable cost and the average total cost lines. And you need to understand exactly why that happens. The next page works that out mathematically if that's what inspires you. So that's talking about long-run costs and short-run costs. That's what, whenever you see fixed costs, that means you're talking about the short run. And so figure 7.5 brings back the isocost graph. If you remember, that's the graph that has the two different inputs on the axes. And they're giving you a geographic proof that the long run is lower cost per output than the short run. That makes sense because you can optimize all your inputs. One of the tricks about fixed costs is that you can't optimize on that input. Once you decide where you are, that's it. It's fixed. So this is another way of showing you the rate of return to making good decisions, which is what we're trying to get out of this course. Then they graph the relationship between short run and long run costs. You should learn that. The most important part is marginal cost, because that's the cost curves that firms use to make their marginal decisions about how much to produce. And then that leads into a discussion of economies of scale. That's always interesting. People want to know if large firms are cheaper than small firms. That's sort of what that is about, which is if you double all your inputs, do your costs per unit double or not? And that'll tell you about economies of scale. Then there's an interesting idea in here toward the end called economies of scope, which is if you're a firm and you produce a second output, how does that change the cost of your first output? So by a second output, I mean a second market, a second type of output. So if you make TVs, should you make video monitors? Something like that. And so you really want to be an expert at these cost curves because we're going to use it for every kind of firm. We're going to use it for perfect competition, we're going to use it for monopoly, and we're going to use it for all the variants in between. So cost curves are sometimes not as interesting as other stuff, but on the other hand, they're really detailed and they capture fully the constraints on the firm, which are the production function and the input prices.